My name is Madzia. I'm from the Institute of Paleobiology of the Polish Academy of Sciences, and the topic of my presentation is the somewhat pliable nature of the phylogenetic relationships within early ornithopods. This presentation is going to be mostly based on a paper published a few months ago by Clint and by Martin Mazur. Actually, you won't hear much more than you actually could see in the paper, because it's mostly based on this, and the topic of the paper was to describe a new basal ornithopod from the Czech Republic. Steve was talking about 4 bones, so I will talk about 1 bone. This dinosaur was first described in 2005 by a team of Oldřich Pfeiffer from the Charles University. It was first classified as an indeterminate iguanodontian, but it seems much more primitive actually. The dinosaur is from Upper Cenomanian. It's about 3 to 4 meters long. Okay, it's just 1 bone, but we can infer this based on the size of the femur. And it was named after Zdeněk Burian and Josef Augusta. Zdeněk Burian is a well-known painter. He was a well-known painter, and Josef Augusta was a paleontologist who actually discovered Burian, so it seemed a good idea to name the dinosaur based on them. All right, while we try to infer the phylogenetic relationships or the phylogenetic placement of the new dinosaur, we face the same problem that many other scientists do while trying to deal with these dinosaurs. Okay, maybe. Okay, so, but can you hear me? Yeah? Yes. Okay. Okay, so our question was actually, what do we actually know about these dinosaurs? Because they are, well, there are some problems with them. There is some, well, we can call it traditional contents of ornithopoda, but speaking of traditional contents is quite tricky because the phylogenetic hypotheses are changing constantly. So there are a few groups that were inferred as ornithopods during the last decades, but this is of course changing, like in the case of Heterodontosaurus that are now firmly placed near the base of Ornithischia. There is something like Thescelosaurus-like ornithopods that we can call Thescelosaurids. There are Hypsilophodon taxa, and then there are the traditional, the typical ornithopods that are called iguanodontians. All right, so I will now move to some groups of these, and I will discuss what we actually know about them, or if we do know anything actually at all. Basically, if it comes to ornithopods, they were divided into 2, let's call more or less informal groups. One is Hypsilophodon taxa, they were more primitive, and the other group was iguanodontian taxa. Among those, the first one, the former, the Hypsilophodon taxa, we had taxa similar to Thescelosaurus from the Upper Cretaceous of North America, but they were not always inferred as a clade. They were, like, let's say, basal ornithopods. Some recent papers, such as that by Boyd and colleagues from 2009, inferred a monophyletic Thescelodontosaurids that consisted just of 4 taxa, and similar topology, which was a bit more species-rich, was inferred by Brown and colleagues in 2013. But these 2 studies actually did not study the position of these taxa on the Ornithischian phylogenetic tree. So the first one, to my knowledge at least, that actually studied the most abundant group of these tassosaurs like taxa phylogenetically was Boyd in 2015. His paper was published in PeerJ, and he actually inferred a relatively species-rich Parksosauridae. He called it Parksosauridae, but he now moved to the more popular Teslasauridae. He actually inferred them outside ornithopods as a sister taxon to Sauropoda, to the large clade that's formed by Ceratopsians, Pachycephalosaurs, and ornithopods. So that was actually the first paper that suggested something like this. And then we have something very strange that's called elasmarians. The name elasmaria was first introduced in 2007 for just two taxa from the mid-Cretaceous to late Cretaceous of Argentina. These taxa were named based on their thin plates on their thoracic region, which is a very problematic character because later analysis they reconstructed different synapomorphisms of them, but I won't talk about details. It would be very boring here. But anyway, it seems that elasmarians might be a thing because Boyd also inferred, they were basically first named just based on two taxa, Macrogryphosaurus and Telencoen. Boyd inferred them as a clade again. Basically, when they appear in a phylogenetic analysis, they always form a clade, so they really might be closely connected. Boyd also inferred another taxon, Notohypsilophodon, as their close relative. A later paper by Rosadia and colleagues in 2016 actually reconstructed a much more diverse elasmaria, but they were pretty unresolved. So if they are a clade, we actually don't know, what was their internal evolution. In order to assess the phylogenetic placement of our new dinosaur, we used the data set first assembled by Boyd in 2015, or published by Boyd in 2015. We added some new taxa to this data set, which was basically expected to be used to assess the phylogenetic relationships of the whole ornithischian evolutionary tree. We added some new taxa from different parts of the tree, including some thessalsaurids, including some dryosaurids, including some, there are even some heterodontosaurids, some ornithopods. We significantly modified some taxa, such as we combined Lesothosaurus and Stormbergia based on study by Barron and colleagues. And we also modified Lelinosaura just to reflect only the holotype, because a study from 2016 suggested that material from the type locality cannot be confidently assigned to the taxon except for the holotype. And we also updated some other taxa. Given that our analysis was based on that by Boyd, some results were pretty similar, such as Teslasaurids were reconstructed outside Ornithopoda. But interestingly, or maybe that could be expected, elasmarians were not part of this clade. Our analysis inferred elasmarians as a basal and relatively species-rich clade in Ornithopoda, so it supports the conclusions. The contents of our elasmaria is almost identical to that of Rosadia and colleagues, so it supports their conclusions. What might be interesting, Hypsilophodon is also inferred outside ornithopods as a sister taxon to Sauropoda, which, let's say, continues the trend to move those former Hypsilophodons outside Ornithopoda, and basically Ornithopoda is today almost identical to what was previously the Iguanodontia. And the basalmost ornithopod, according to our study, is Gideon Mantelia. All right, but there are still some problems. And the most apparent problem is the long Gauss lineages. For example, if it comes to this tree, which is from Boyd, his time-calibrated tree shows very well that if such topology is correct, then we have a huge Gauss lineage leading to thesaurids. So if thesaurids are really outside ornithopods and in this position, then they had to appear somewhere deeply in the Jurassic. And we have no Jurassic taxa belonging to this clade. So what can we do in future to actually, change this or make it more accurate? Ornithopods are not studied using more than a single phylogenetic method. So it might be a really good idea to use other research strategies or use entirely different phylogenetic methods, such as Bayesian inference. All right, I would love to thank people that made this actually possible, and especially Boris Ecker from the National Museum in Prague, who granted me access to the type specimen. And I would also love to thank Edita Felsin from Poland, an extremely talented illustrator who made this extremely improbable restoration of Buranosaurus. So here are the references that I used, and I thank you very much for your attention.